I will use this example to explain two-sample t-test. Uh, so the statistic for comparing two means will be something like this one. Okay, so the numerator is the difference of sample mean for two different samples, and the denominator is the standard error of the difference of mean. And the exact formula to get the standard error so depend on whether the variance are equal or not. Okay, and we will explain them in more detail later. And how to evaluate p-value depend on what the alternative hypothesis is. So whether it is two-sided or maybe greater than or equal or smaller than, according to this different scenario. And we have different ways to calculate p-value. Yeah, so this is very similar to one sample t-test. And if you want to get a confidence interval, so then you just use the difference of the sample mean plus minus a critical value times the standard error of the difference of mean. Again, so the standard error, the calculation of standard error, so depend on whether you have equal variance or not. Okay, so let's try to explain the steps in more detail using this example. Uh, how quickly do synthetic fabrics such as polyester decay in landfills? A researcher buried polyester strips in the soil for different lengths of time, so then dug up the strips and measured the force required to break them. Breaking, breaking strength is easy to measure and is a good indicator of decay. Lower strength means the fabric has decayed. Part of the study buried 10 polyester strips in well-drained soil in the summer. So 5 of the strips chosen at random were dug up after 2 weeks. And the other 5 were dug up after 16 weeks. So the data is listed in this table. Okay, so we have two samples essentially. So one is 2 weeks, so one is 16 weeks. And for each sample, so we have 5 observations. So the first step usually, so we will calculate some summary statistics. Yeah, so first we will have n, the sample size, the sample mean, and the sample standard deviation. Yeah, so sometimes as a problem may give us variance, right? Variance. Yeah, so basically, so this is s and this is s squared. Okay. Is there any difference that the mean breaking strength after 2 weeks is larger than that after 16 weeks? So if we denote this as mu1, so this as mu2, right, we can see. So what we want to prove or what we want to find evidence for is mu1 greater than mu2. Yeah, so basically the non-hypothesis, alternative hypothesis. So we first figure out alternative hypothesis, right? So the alternative hypothesis will be mu1 greater than mu2. Mu1 greater than mu2. And the null hypothesis will be the complement. So basically mu1 smaller than or equal to mu2. So let's try to calculate the test statistics. So first assume first we assume the equality of variance. Okay. Assume equality of variance. Okay. Yeah. So if we assume variance are equal, so the first step is we want to calculate pooled standard deviation. Pooled standard deviation. So pooled standard deviation, according to formula, so this will be square root m1 minus 1 times s1 square plus n2 minus 1 s2 square over n1 plus n2 minus 2. So in this formula, we can see, so n1, n2, so will be the sample size for the first sample and the second sample. So in this question, in this problem, so both n1, so this is n1, so this is n2. So both n1 and n2 are equals 5, okay? And so S1, S2, so S1, S2, right? So will be the sample standard deviation for the first sample and the second sample. So here, this is S1, this is S2, okay? So now we find all the value, right? So then we can plug in them to here. So we will know, okay? And so 5 minus 1 will be 4. So 4 times 4.60 square plus 4. So this is n minus 1. So times 16.09 square. Okay. And so divided by 5 plus 5 minus 2. So then you do the math, you got 11.833. And so this is the broad standard deviation. And the next step, standard error. Standard error of x1 bar minus x2 bar will be SP. So broad standard deviation times square root 1 over n1 plus 1 over n2. So we've already calculated broad standard deviation. Okay. And both n1 and n2 equals 5, right? So this is 11.833 times square root 1 over 5 plus 1 over 5. So then you do the math, you got 7.484. Okay, so then you get the standard error. So the test statistic T0, so is x1 bar minus x2 bar divided by standard error x1 bar minus x2 bar, right? And see, this is x1 bar, this is x2 bar, right? So they are just the sample mean for the first and for the second sample. So you plug in the value. So this is x1 bar is 123.80 minus x2 bar 116.40 divided by standard error. So we've already calculated standard error, right? So it's here, so we put here, right? So divided by 7.484. Okay, so then you do the math. The statistic is 0.989. And so for p-value, so p-value just is the probability t greater than t0. So we use greater than t0 because, see, this basically should be consistent with whatever we have in the non-hypothesis. In the alternative hypothesis. Greater than or equal to. Okay, so basically it should be in the same direction as in this alternative hypothesis. Okay, and for p-value, and so this is the probability that t greater than 0.989, and we cannot calculate this by hand, and we have to use Excel, and so this is basically so 1 minus t dist 0.989, and so then degrees of freedom. So degrees of freedom, so here will be n1 plus n2 minus 2. So basically will be 5 plus 5 minus 2, and we got 8. So this is 8, so this is 2. Okay, and so then you run this function in Excel, and so you will get p-value. So the p-value is equal to 0.176. Yeah, because so this p-value, so this value is greater than alpha. Alpha is 0.05 as a significance level. So then we fail to reject as a non-hypothesis. And so this is the test. And we can also get the confidence interval. And so the confidence interval, 95 confidence interval for the difference of mean. Okay, so will be x1 bar minus x2 bar plus minus critic value times the standard error. Okay, and x1 bar, x2 bar, so we can get the value from the problem. So this is 123.80 minus 116.40 plus minus. So the critical value here will, we cannot get the number by hand, and so using Excel, so this is INV 0.975, degrees of freedom 8, right? And get this in Excel, and so the value will be 2.306 and times standard error. And the standard error we've already calculated here, right? See, basically, so this is standard error. So we times standard error 7.484, right? So then we get the confidence interval. Okay, and so if you complete the math, the confidence interval will be negative 9.86 to 24.66. Okay, yeah. So basically, so now we just demonstrate how to do the test and how to construct confidence interval if we assume equality of variances. So now, if we assume inequality of variance, the formula will be slightly different. Let me first erase all those calculations. Okay. Okay. So now, if we assume inequality of variances, okay, so still the test statistic will be x1 bar minus x2 bar over standard error of x1 bar minus x2 bar. Yeah, but how to get the standard error is different. So in this case, the standard error of x1 bar minus x2 bar will be obtained as the square root of s1 squared over n1 plus s2 squared over n2. Yeah, so we've already mentioned, see, this is x1, this is x2, right? And we plug in the value 4.60 squared over 5 plus 16.09 squared over 5. Okay, so then you do the math and you get standard error. So 7.484. Okay, so you plug in the value. The standard error is 7.484, and so the difference of mean will be 123.8 minus 116.40. Okay, so you do the math and you get test statistic, yeah, 0.989. Yeah, you may notice the test statistic here is equal to the test statistic when we assume equality of variances. This is just an accident. Usually, so these two mean will be different. Okay. So now we get the test statistic. So now next we want to get the degrees of freedom. The formula here for degrees of freedom is really complicated. Yeah, you will see. So this is s1 squared over n1 plus s2 squared over n2 squared. And so then 1 over n1 minus 1 times s1 squared over n1 squared plus 1 over n2 minus 1 times S2 square over N2 square. Well, it is complicated, right? Yeah, but it only involves S1, S2, and N1, N2. We've already know so what is the value of N1, N2, and S1, S2, right? See, we can just try to plug in the value. So S1 is 4.60 square, so over 5, sorry. Okay, and so then plus 16.09 square over 5 square, and so then 1 over 5 minus 1 times 4.0 square over 5 square. Yeah, so pay attention, see, we have square and then we have another square, okay? And so then plus 1 over 5 minus 1 times 16.09 square over 5, and then square. Yeah, see, notice, see, we have square, square, and then square, right? We have square and then square, okay? Yeah, so after that, so you do the math, and you got degrees of freedom 4.65, okay? And the p-value is similar. Yeah, so here again, so we cannot get the p-value by hand. We have to do it using Excel. Okay, so this is p-value is still probability that t greater than 0.189, and so here so should be 1 minus t this not sorry, so should be 989. Okay, greater than 0.989. 89, right? And the degrees of freedom we just calculated. Okay, so 4.65 and then 2, right? Yeah, so this is p-value. Okay. Again, so you can get a confidence interval. So the confidence interval, 95% confidence interval will be x1 bar minus x2 bar plus minus critic value times standard error. And the x1 bar, x2 bar, right? So we can read from the problem. So 123.8 minus 116.4 plus minus. So now the critical value here so will be TINV 0.975, and so the degrees of freedom will be 4.65, right? So then you can get a degrees of, you can get the critical value, so 2.63 times the standard error. We've already calculated standard error as 7.484. Okay, so then you will get the confidence interval. Yeah, so basically, so this example so just explains how to calculate two-sample t-test. Yeah, so what's important is you need to be careful. So whether you assume equality of variance or assume inequality of variance. So in these two scenarios, and the formula to calculate standard error and to calculate degrees of freedom are different.